All right, hello again everyone. In this video we're going to be taking a look at the midpoint formula. And what the midpoint formula does, as you might be able to tell by the name, is it allows us to determine the coordinates of the midpoint of a segment that would be on a coordinate plane. So if we know the coordinates of the endpoints, like you can see down here I have segment AB. If I wanted to know the location of the midpoint of segment AB, if I know the coordinates of the endpoints, the midpoint formula is what's going to allow us to do that. So before we jump right in and just look at the formula, let's see if we can figure out where it comes from. Let's get an idea of why this formula that I'm going to show you down here in a minute, let's get an idea of why it works. So you can see I got a little instruction for you that says, take a look at this diagram and how can we determine the coordinates of M, the midpoint of segment AB, and that reminds me I need to change that to an M real quick. So how can I determine the coordinates of that point M right there? Well, you'll notice I didn't actually give you the coordinates of A and B, and I'm not going to put any actual numbers on these because I want to see if I can determine just in a general sense what would the coordinates of M be for any possible coordinates for A and B, not specific ones with actual numbers, but just more general coordinates. Like for instance, if we called A, if we said A was at point x1, comma y1, and B had a coordinate of x2, y2, then what would M's coordinates be? And so how can we do that? Now I'm going to show you what we might be able to do. First thing I'm going to do is I'm going to add a few lines to my drawing here. I am going to first add a line right here that is parallel to the y-axis. So this is parallel to the y-axis right here. And I'm going to add another line that is going to be parallel to the x-axis. So in other words, a horizontal line that's going to be parallel to the x-axis right here. Now you can see those 2 points are going to intersect right here. So let's call that point, let's just call that point D. Excuse me. What would the coordinates of point D happen to be? Well, if this line is in fact a vertical line parallel to the y-axis, then this point, point B, and this point right here would all have the same x coordinate. These would all be at the same place in terms of their location on the x coordinate, or on the x-axis. So this x coordinate would be the same as the x coordinate of point B. It would be an x2, whatever that would happen to be. Now what about the y coordinate? What about the second part of the coordinates of point D? Well, it's on this horizontal line that also goes through point A. So this horizontal line that goes through point A, it hits this point on the y-axis, which we know is going to be y1. Every point on this horizontal line would have the same y coordinate, y comma 1. I'm sorry, y sub 1. So point D right there has a y coordinate of y1. So point D is x2 comma y1. Same x coordinate as point B, same y coordinate as point A. Now I'm going to add a couple more lines in. I'm going to come straight down from M, right here, and that's going to be parallel to this line and to the y-axis, and it's going to intersect right there. It's going to intersect this horizontal line that I drew. So we have a point there, let's call that point E, where this new line intersects the horizontal line AD. And I'm going to draw another horizontal line that's going to come over here, and it is going to intersect line BD. We'll call that point F. All right? So now let's think if we can figure out the coordinates of point E. All right, what is its x and y? What are its x and y coordinates? Well, first of all, we know what the y coordinate would be because it's going to be the same as the y coordinate for A and for D. It's going to be that y sub 1 number, whatever that would happen to be. But what about its x coordinate? What's this going to be? Well, one of the things I know, it goes back to something we learned a while back in math or in geometry. If we have this line right here that is parallel to one side of a triangle, right? Because we have a triangle here at ABD. Triangle ABD, take a look at that. This line is parallel to one of the sides of triangle ABD, and it goes through a point that we know to be the midpoint of another side. And when that happens, when you have a segment or a line that goes through a midpoint of one side of a triangle and is parallel to another, we know that it goes through the midpoint of the other side. So E, we now know to be the midpoint of segment AD. And we can kind of get an idea of what the x-coordinate then would be, because if the x-coordinate of A is at x1 and the x-coordinate of D is at x2, that's going to be right in the middle between those points, x1 and x2. Well, how would we find the middle point between two numbers, really, right? If this was a 1 and this was a 6, what's in the middle of 1 and 6? Or if this was a 2 and this was a 10, what's in the middle of 2 and 10? And the way we would do that is, well, if you think about what's in the middle of 2 and 10, what's right there in the middle? Well, what's the difference between, what would maybe be the average of 2 and 10, right? Because if we want to find something that's right in the middle between two numbers, really what we do is we'd find the average. Well, that would be a 10 plus a 2 divided by 2, or 6, right? 6 would be right in the middle of 2 and 10. So how can we apply that to this picture up here? We can say that this point right here, which I think I'm going to need to give myself a little bit more room, we can say that that x-coordinate right there is the average between the x-coordinate of A, x1, and the x-coordinate of point D, which we know to be x2. So if we add x1 and x2 and divide by 2, that would be the x-coordinate of this point E. Now we can do something similar over here with point F. It's the same idea. This line we know is going to be parallel to this side of triangle ABD. It's parallel to segment AD. It goes through the midpoint of segment AB. So that means that F would also be the midpoint of segment BD. So that means for F, of course, it has the same x-coordinate as B and D. So it has an x-coordinate of x2. But then the y-coordinate would be the average between y2, which is the x-coordinate of B, and y1, which is the y-coordinate of, let me start that over. It's going to be the average between y2, which is the y-coordinate of B, and y1, which is the y-coordinate of D. So the average between those two would be y2 plus y1 divided by 2. So it looks kind of funky, but hopefully you understand where this is coming from. This point E has an x-coordinate that's the average between the x's for A and D. Point F has a y-coordinate that's the average between the y's for B and D. Now where does that leave M? Well, M would have the same x-coordinate as E, right? It's going to be in the same place on the x-axis as point E is. So point M's x-coordinate is going to be x1 plus x2 divided by 2. Point M's y-coordinate will be the same as F, which is y2 plus y1 divided by 2. So there we have it, right? That should be a way that we can figure out the midpoint of any segment, because you can see where the x1s and x2s come from. Those come from the endpoints of segment AB, right? And the y2s and y1s, those come from the endpoints of segment AB. So if point A is at x1, y1, and point B is at x2, y2, then the midpoint is going to be the average of the x's and the average of the y's. And that's what 13-5 is telling us right here. Oops. 13-5 is the midpoint formula. It says the midpoint of a segment that joins points x1, y1, and x2, y2 will be the point that's located at x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Or another way of saying it is this one would be the average of the x's. This is the average of the y's. And by x's and y's, you know, I'm talking about the x's in the endpoints and the y's in the endpoints coordinates, right? So average the x's, average the y's, those two numbers give you the coordinates of the midpoint. So let's do a couple examples. Find the midpoint of segment AB, and I'm giving you some locations of the endpoints A and B. So for example 1, we have 6, 3 and -2, 5. So that would mean the midpoint is at the average between the x's and the average between the y's. So what are the two x coordinates? 6 and -2. So I'm going to add 6 plus -2, and then I'm going to divide by 2. Then I'm going to add the y's, which is going to be 3 plus -5, and I'm going to divide by 2. So 6 plus -2 is 4. So I got 4 divided by 2, and then I have 3 plus -5, which is -2 divided by 2. So that would tell me that the midpoint is going to be at 4 divided by 2, which is 2, comma, -2 divided by 2, which is -1. So there's the midpoint between these 2 points. I averaged the x coordinates, 6 plus -2 divided by 2. I averaged the y's, 3 plus -5 divided by 2, and that made up the coordinates of my midpoint. Now in example B, I'm throwing a little bit of a curveball at you. I have, instead of numbers, I have some letters, right? But we're going to do the same math here. We're going to take the two x's, add them together, a plus c, and divide by 2, comma. We're going to take the two y's, which happen to both be b's, b plus b, divided by 2. Now let's see if we can simplify this at all, right? That would mean, well, a plus c we can't really do anything with, so that's just going to stay as a plus c over 2. But b plus b is 2b. And then if I have 2b over 2, then we can simplify that a little further. We can leave the a plus c over 2 alone. But 2b over 2, these 2's would cancel out. So that would just be a b. So the midpoint would be a plus c divided by 2, comma, b. Now in this last example, you can see I'm giving you one endpoint. I'm giving you the midpoint and one of the endpoints, and I want you to find the coordinates of the other endpoints. So in other words, we have something like this. We have on an xy axis, we have x at somewhere down here, 4, -8, right? Here's x. We have a midpoint of 4, comma, -2, and then so that's the midpoint. So now that means somewhere up here is y, right? Because here's segment xy with a midpoint at M. How are we going to figure out what this coordinate is? Well, I know that that midpoint, 4, -2, the 4 comes from adding the two x's together and dividing by 2. So x is at 4, -8. Midpoint is at 4, -2. Y is at something, comma, something. So 4 plus what x? 4 plus what x divided by 2 would give me 4. 4 plus x divided by 2 needs to give me 4, where this x is this mystery number right here. Well, if I put this over 1 and cross multiply it, I have 4 times 2, which is 8, equals 4 plus x times 1. So that's just a 4 plus x. If I subtract 4 from both sides, I get a 4 for my x. So I know the y coordinate, or the x coordinate of point y will be a 4. So I'll just put a 4 in right there. Now if I'm looking for this y, I know that -8 for the y coordinate of the first point plus that mystery number divided by 2 needs to give me -2. Put that over 1, cross multiply. -2 times 2 is -4. That equals -8 plus y, because -8 plus y is going to get multiplied by 1. I add 8 to both sides. I get 4 equals y. So my y coordinate of point y is 4. So y right here, that's going to be at 4, comma, 4. All right, looks like I'm about out of time for this video, so we'll see you the next time. Good luck.